All right, so a small disclaimer about this. I usually start with a disclaimer. It's always different, though. I've been talking to, is Jeff Williams in the audience? Okay, so I've been talking with Jeff a fair amount. I gave a version of this talk at QCon out west, and we talked a lot about an OWASP threat modeling project as a result of it. And what occurs to me, actually, is that threat modeling is kind of one of those advanced techniques. It's one of those things where you have to sit down and think real hard about what could possibly go wrong with your software. And in a lot of regards, that's quite difficult, and it may not even be necessary. So how many people are building web apps in Java here, right? How many of those are 3-tier? How many people are starting to use some of the Web 2.0 and 3.0 stuff, right? So my guess is that if you were going to draw some boxes and lines about your system, they might look a lot like everyone else's. And so what we're striving to do, rather than teach everyone to spend a month doing threat modeling, we'd really prefer to build you a threat modeling cookbook that you can use and extend. Notwithstanding that, there is still a need for your business logic, your applications that don't necessarily support the OWASP, kind of 3-tier Java.NET idiom, to actually think about how those applications could be penetrated and what you're going to do in order to either test to see that they don't actually fall prey to those vulnerabilities, run static analysis, or alternatively do some secure design. So think of threat modeling actually as the step that you do to think about what things aren't on the checklist. And so you're not going to want to do that for all of your applications. You're not going to want to do that thoroughly for all your applications. You're going to want to base it on risk. One more disclaimer. This is actually a 4-hour presentation, so I'm going to attempt to compete with Dennis Cruz in terms of word speed, and leave behind all the slides so you can look at them in greater depth. The first thing to talk about is what is a threat. There's a lot of confusion about what a threat is and what threat modeling is, because everyone who's published a book or paper on this topic seems to have ignored everything that came before them. You can go back to the mid and early 70s and people were talking about threat modeling. The Microsoft book and other books on the topic seem to have basically just ignored that stuff. So what we're going to say is there's a lot of different definitions. There is a lot of confusion. We're going to talk about a threat being an agent, someone or someone's software that can attack you. And there's these other words that I will try to use very consistently, like attack vector and an asset under attack. And there's other words that you'll hear bandied about. If you saw Dennis's talk on O2, you heard about attack surface. So what is an attack surface, and what is an attack vector, and what is the attack delivery? One of the things that when I have a whiteboard and give this as a class, we actually build a table and we start to talk about who will do the attack, what they will actually use to deliver the attack, what the attack will entail, and then what the consequences of that attack are, what that attack's operating on. It's key to think about all of those concepts, because if you don't, you're not going to be thorough about having looked at the worldview of what could possibly go wrong in your application. What most people forget is they forget to think about the who. They think about the specific kinds of attacks that are in the checklists, and they think about some definition of attack vector, but they don't remember to think about who. They don't think about people like insiders or malicious developers. And it may be that your organization doesn't need to think about those things. If you're in a financial shop, my guess is that you're about to get smaller, if you haven't already. And if you had 4,000 developers and next month you have 2,000, you may have 2,000 angry ex-developers. And so thinking about what these people have access to and what the attack surface of your application looks like relative to that is interesting. We'll also talk about, if you're not concerned about insiders, how external threats can increase their privilege to the extent that they can actually begin to look like internal threats. And so the notion of an internal, who's internal to your application, when you really start looking at the design, actually gets quite dubious quite fast. So in thinking about, I'm not going to attempt to fight the vocabulary war here, but the moral of the story is if you think about who, and you think about their motivation, you think about what they're going to use to actually break the system, you're going to end up more thorough. So what is a threat model? It's actually really hard to answer this question because we don't exactly have a common nomenclature and symbology for design. So if we don't have a way that we can consistently talk about and draw designs, then it's impossible for us to come up with a way to talk about threat models. Because threat models are, in essence, an annotation of design. So in some sense, in defining threat modeling, we're doomed to fail. And because we can't agree on how to write down our designs. But the things that we want to look up is kind of where the attack surface is, who can attack the system, and what they might be willing or interested in compromising. We can talk about the probability of attack and estimation, and we can weight impacts. Sometimes weighting the impacts is far more easy than actually the probability of attacks. So we can talk about things like discoverability and exploitability, and we'll talk about that. My suggestion is that we look at the impact of attacks and we prioritize based on impacts, and we not get wrapped around the axle of probability. Really, threat models in my mind are the intersection of your goals for the system, how misuse of the system could occur, and how those goals would be violated. And I'm going to go over the general process quickly, and then we're going to dig into some techniques that me and my guys have found useful in helping people with secure design, in helping people with code and architecture analyses to figure out who can attack their system, what design elements might be vulnerable, and then how to test it. I did give you the disclaimer that there can be no, authoritative, symbology right now. I'm going to throw up some stuff that has been useful and scrubbed from our environment and from our assessments. These diagrams, you can feel free to use them. They're hybrid. Those of you who are UML purists or particular other diagramming technique purists are going to sort of be agitated because they're hybrid diagrams of structure and behavior. Each of them is meant to show a particular type of thing. Really what's key here is not the actual look of it, but what we were doing and what we were considering. And if these slides are not available, which I believe they are, I sent them a month or so ago, just ask. So what are the elements of a threat model? We know that we're going to need a structural view of the system. We're going to need a structural technical view of the software and the application. Network topology diagrams will not be sufficient. We're going to need to know who could abuse the system and where, much like in a misuse case or a use case, where those actors would interact with the systems. We're going to want to know what aspects of the system that they're going to want to interact with. That will include things and functionality. So assets are not just a database table. There are going to be attack vectors, and there's going to be this notion of privilege and trust. And this is something that we, security consultants have been arguing about the usefulness of for some time, and I'll talk a little bit about sort of our frustration with regard to trust and privilege. These things we'll actually find are kind of less useful than this thought process over here. But they're the things people routinely consider when they consider threat models. I converted a lot of my diagrams to scaling EPSs, so they should be more readable than this. If you're having trouble understanding, please just yell out some aspect of it and I'll explain it more fully. We'll find that, though, we have a few different kinds of annotation that we're going to add to these diagrams to show things. And for those of you, how many people have been participating in a design review or some sort of architectural analysis of the software, or maybe even secure design? Okay, a lot. So we'll find that different ways of picturing the structure of the software will actually illuminate different things that we should test for. in my mind, this will help us drive security testing, drive code review, drive fuzzing, further analysis. And I'm going to show you a bunch of different things you can throw at the diagram, whether they be color overlays or little stars or something you can put in boxes to point out to yourself where interesting stuff will occur. One way to think about threat modeling in a sentence is, if you have a million lines of code in your application, it's a fairly decent sized application, finally, where are the pieces that you would look at if you only had 5 days to look at it in order to find where the problems are most likely going to occur? That's what we're after. And the high impact problems. With regards to threats themselves, remember I talked about them being a who, not a what or an attack. And that's important because I work a lot more probably with developers than I work with security guys. And this is a completely non-functional relationship that we have between security guys and developers, in my opinion. We need rules of engagement. And in my mind, defining who you're willing to think about attacking your system are a big part of that rules of engagement. So if insiders are off the table, they're off the table. Developers should use and reference threat models to get the security guys off of their back when they come up with some whiz-bang, crazy, ridiculous attack that your organization is not interested in, or that you have compensating controls in place to take care of, whether they be completely off axis like insurance or liability transfer or contracts, or actually technical compensating controls like a proxy that's going to force authentication and things like that. So we want to think about who, and we want to think about in terms of capabilities and skill levels, and the resources and tools they have available to them. We want to define what this person could do to the system. We're also going to want to talk about motivation, but I'm going to treat that separately. In any rules of engagement, we have to figure out what the capabilities of the people we're willing to protect against are. I've done high-end assessments for some of my clients, and we've gotten down these rabbit holes and everyone in this room has probably asked or answered this question. So I have to use credentials to connect to the database. Where am I going to store these things and how on my web server, right? Is there anyone here that hasn't, faced that question in some form or another? So you get down these rabbit holes talking about whether or not someone could reverse engineer a config file, whether they could own a host. You need to figure out who you're protecting against so that you can answer questions like whether or not that question is worth answering quickly. So are we talking about someone who has access to servers in a particular network zone? Are we talking about someone with reverse engineering skill? Oftentimes when you get to the bottom of that rabbit hole in a conversation with someone, you end up talking about someone who needs NSA level reverse engineering skills, infinite time, and the ability to operate and look at your systems without being detected for months at a time. And when I think about that kind of threat, I'm thinking about concerted professional attack or foreign government. And I submit to you that if you're a company attempting to protect against your own government, you're in a different business than I'm familiar with working at. And so those are things you can just take off the table. So thinking about this notion of and so when you ask questions about, okay, well, what do we have to do to the config file, for this application or this web container? Think about the capabilities it would take in order to get access to them. And you'll start to come up with equivalence classes for things pretty quickly. We'll talk about that in a bit. Just documenting these is an important exercise, and it's a little bit draconian, but you really only have to do this maybe once or a few times, depending on how disparate the business units in your organization are. In my mind, this is a task best done by the central security office, the corporate security office. They have the best view of what all the business units are going to need to consider. And in some sense, they may actually be able to talk about threats being pertinent to one business unit or another, and not all of them. This is going to help us, when we've characterized someone's capabilities and their skill levels, it's going to help us quantify their motivation for misuse a bit. And it's going to help us figure out whether or not they're going to have at their disposal particular techniques. Again, the corporate security office should enumerate the threats of how, because they're defining what you have to think of to be thorough about considering threats. Developers should participate as stakeholders in this process because they need to be the bullshitometer, right? They need to prevent against, the mission impossible threat scenario, where it's a 5-stage attack that requires inside information and wire work. Before I jump into the details of how we do this and how we've helped people do this, I wanted to kind of talk about the alternatives because there are some out there, and it's important. I'd like to talk about Stride. Are people using Stride here? Okay, so in my mind, if you were going to boil down in a cheeky way what Stride is, it's a conceptual checklist backed with data flow diagrams. There's a few concepts. The conceptual checklist is basically the message digest of Ross Anderson's security engineering book, which is tremendous, and you should absolutely read it if you're doing secure design or doing architectural assessments. But Stride is basically the acronym for remembering those elements of that book, security engineering concepts that map easily to security controls. So if you're a government, semi-government, or non-profit organization, you're very into talking about attacks and controls. And when you think about spoofing, and when you think about tampering, you can think immediately, almost in knee-jerk fashion, about the controls that an application should provide in order to fix those. So this is a good start. But when you go from that conceptual level to this, now you're looking at something that a unit test writer would consume to write a particular test case or a set of test cases around a portion of a test document. And this makes a lot of sense when you think about the way that Microsoft works, because they're a massive software producer. So they have a development QA-oriented culture, and they're a product company. So when you think about applying a checklist of engineering concepts to a massive testing effort, that's going to make a lot of sense for Microsoft. If you're a product company, I recommend looking at things like Stride because they will fit your culture. If you're a bank, my guess is that you have a tenth of the security/QA people that are needed in order to get to the data flow diagram level and then build a comprehensive security test suite around it. So there's good and bad to it. For those of you, anyone familiar with the OCTAVE process or followed anything? Okay, so this is a heavier weight risk management methodology. It has all of the features that a good risk management methodology should. It has a loop. It has boxes. It has way more things than you can afford to do. Actually, Cigital's process for architectural analysis and for threat management is sort of very compliant to this view of the world. And that's great, but if you've gotten a quote off of us for doing analyses, you know that in some sense we're a fair bit higher in price than the competition. And the reason is because we do sit down and we think about the business goals and we do go through the loop. And a lot of organizations are thinking about a 5-day code review followed by preceded by a 1-day design review, and they don't have the opportunity to do that kind of weight. So I'm not going to really talk about, there's more than enough documentation on the OCTAVE process, and you can dig into it. As an alternative to both of these, I wanted to kind of get a little bit sort of older school and go back to kind of the Ed Amoroso, 70s threat modeling, followed by Bruce Schneier's notion of attack trees. And this was something we used to do a fair amount, and we got away from. And the thinking here is that you can basically come up with a conceptual way to attack the system and then enumerate in classic tree format all of the different possibilities that could make those attacks realities. Then the process of securing your design proceeds by finding the choke points and cutting off the viability or the feasibility of those kinds of attacks. The advantage to organizing your thoughts in this manner is you can annotate each node with a weight. The weight can be cost, it can be effort, it can be probability, it can be impact, it could be some combination of those. And you can use classic, sort of accounting and Boolean logic to figure out what your total risk is and make decisions based on it. If you do something like an attack tree enumeration, you're going to probably be thorough. Another name for this, for those of you who are familiar with like sort of old DoD stuff, is vulnerability hypothesis testing. The objective of this is to become thorough and to document your complete thoughts on it, and then you can prune and subtree from there. If you're a risk-based organization, the mathematics of this may appeal to you, but you're going to, when you do your first attack tree or your third attack tree, enumerate far more possibilities than your testing efforts and your secure design are willing to deal with. So the advantage to an approach like attack trees is thoroughness. The disadvantage to them is you're going to waste effort. And you're going to waste effort at, of course, the expense of time and money. So what do we think a threat modeling process should look like? I'm going to talk about this at the high level, and then I'm going to dig into the detail of it in much more length. I'm going to kind of breeze through each of these slides because there's 2 to 5 slides associated with each of these concepts moving forward. In my mind, threat modeling is used to identify where the potential threats exist relative to the technical architecture, and to figure out how these threats can escalate their privilege and become more formidable than what everyone starts with access to your system, which is an unauthorized internet-based user. Right? Very little privilege, very little capability. It specifies what things you have to decide whether or not the application is vulnerable to, and it identifies components and assets worth protecting. And as we'll talk moving forward, it's really the interface of the technical decisions you've made in order to engineer a solution and what vulnerabilities they bring with them as a result of all of the consequences and assumptions associated with them. The ounce spring MVC discovery is something that we had threat modeled literally 5 years ago with regard to general MVC architecture, and have been looking for in assessments for that amount of time. It's about the consequences of the technology tools that we're choosing and how they allow for misuse. I'd mention a word around this because anyone who's tried to do threat modeling or tried to do security testing or tried to do misuse case elicitation immediately hits a sticking point. And the sticking point they hit is, where do I start what is too obvious? What can I take for granted? And where do I end what is too baroque and crazy? And I would argue that things like the Owasp top 10 and checklists should be left off of your threat model. Now, if you're doing a risk management exercise, they should not be left out of your risk management exercises. But again, threat modeling is basically a conduit on which you can do the thought process of thinking about what else could happen to your application. In my mind, the Owasp top 10 is a cached result of a threat model on a web application, right? So we've thought about web applications, we've thought about the technologies, and these are the things that go wrong. If you haven't looked for the Owasp top 10 in your application, you probably don't want to start with a 1 week long threat modeling exercise. You probably want to look for those things and remove them from your application, because there are automated penetration testing tools that can find and exploit these vulnerabilities. Right? So that's job one. Now, the thing that checklist will never give you is what's wrong with your business logic that could be misused and exploited by someone who is well motivated and has the appropriate capacities. That's where we're going to use this, right? Does that make sense? So leading up to it, there's some things, and you can see sort of, I've mentioned risk a variety of times. We're going to tie this technical risk to the business assets and to the design, and we're going to show how it's possible for attacks to actualize. And really what we're doing is we're doing a planning exercise. The output of a threat model is a bunch of work you're going to have to do. You're going to have to validate whether these vulnerabilities in fact exist, and you're going to have to conduct some secure design exercise in order to mitigate them. So there's going to be a few things that we have to do before we can really, and so people ask, where does threat modeling begin? Where does misuse solicitation end? Where does architectural analysis pick up from it? Those questions are sort of, they're going to persist because not a lot of this is well documented. these books here describe at a high level, you know, those activities and where they fit together, but they're sort of unsatisfying in as much as they don't tell you exactly how to do them and what the outputs of them are. And I think in a lot of regards, because everyone's organization has sort of, in some sense, ended up rolling their own process, you're going to have to help answer those questions. I think that this community can build a cookbook that will help us, but everyone's going to have to salt and pepper to taste. The things we need to do before we can really consider our threat model, you know, underway is we're going to have to identify the who. We're going to have to identify the threats. We're going to have to enumerate what things that those people are going to be interested in doing, so we can figure out how they would actualize those attacks. And that's going to be where the vulnerabilities are going to be elicited. They're going to do that through misuse and abuse, and we'll talk about kind of how to get your first cut of the threat model through that quickly. You have to diagram the structure and assets of your applications, and because we're going to anchor all of this in design, and because you probably don't have a design document for your application, this is going to be, you know, one of the first technical steps we do. Then we're going to start to annotate it and figure out whether or not that enumerates some things we're going to have to go after an attack. So just a few words on what the inputs are up at the top before we move on. And this is, if this is a 4-hour course, this is where some of this stuff becomes exercise. The first thing we have to do is, after we've defined who, is we have to enumerate the Doomsday scenarios. And this is the hardest part for developers. It's the easiest part for spooks and security guys. What would so the thing that I say is, if you're a developer and you gotta enumerate what the attacker might go after, I don't want the row from your database. They don't really care, right? They may want recognition, or they may want to be able to get into DEF CON, you know, for free. They may actually have financial gain. I mean, if I steal your credit card, I can sell it for $50. You know, so there may be an actual commodity market there. But think about what would put your company out of business, or what would get your boss or your boss's boss fired. And those are actually harder problems to answer than you'd expect. So, for instance, you know, working on these phones, right? So what are some of the Doomsday scenarios? One of them would be if I could send an SMS worm that would brick every phone, right? I can put a price on that, and we can go after that attack. What in your organization is the equivalent to that, right? Misuse and abuse. If you have, this is like the ghost use case. I'm really not sure why that didn't come out. If you have usage of an application, and so this is supposed to be a use case of someone editing their profile on a networking site, so MySpace or Facebook or something like that, and you know, we're going to start to think from a misuse perspective. That's normal use. I'm editing my profile. What negative things could occur that would be misuse of that same functionality that might be interesting? So if I'm editing my profile, am I allowed to put HTML tags in that are bold that say, I really like this movie? Is that an undocumented feature if that works? Yeah, it's probably an undocumented feature, but what happens if I put script tags in, right? And now we're in a scenario where, okay, well, this is actually code that I'm putting up there, and can that code, you know, actually end up in a you know, type of attack? And so misuses, this slide was animated, but it's not going to work, unfortunately, will be very helpful. The two things that I tell people is the first set of threats you should enumerate for your application are normal users who are doing one of two things. The first thing is behaving as dumbly as possible, right? How could they abuse the interface and just do dumb stuff? Now, when you do that kind of misuse solicitation, you're really starting to drive intelligent fuzz testing, right? Because you're going to start to think about the things that you'd want to actually test in your application that may break it. The second thing is, what evil could they do to mess with the application? So if you think about dumb and you think about evil, you're going to have misuses that will probably drive you know, breaks in your software just from the interface. Another good ripe entity to drive some of threat modeling behavior is the specified security features. when I asked what a good security requirement was at S3, about 5 years ago now, John Villegas screamed, use 128-bit encryption. And I thought, well, that's the best negative example I possibly could have asked for, right? So if your requirements documents, if your specifications say stuff like this, then think about misuse and abuse of these things implemented correctly, right? If I'm encrypting something, what was it that I was using the encryption for? Was I trying to protect the privacy of information? Was I trying to prevent against replay? Is the kind of structure I've provided the data I've encrypted going to prevent against replay? Those of you who saw Gunnar Peterson's web services tutorial or talk, he shows very simply how you can start to use security features like WS security and encrypting messages that are still vulnerable to very obvious attacks or more subtle replay attacks. So mining your security requirements for things that are very specific but have nothing to do with what the application's actually trying to prevent is a valuable place to look for places to abuse. And we say at Cigital that software security is not security software. That's actually a Mike Howard quote, so not to misrepresent that. But I'm not sure if it's still the case, but there was certainly a time when we could basically guarantee if we looked at the security requirements for an application, we would have to go no further to break it. So once we've gotten some of these inputs, the who's, what could turn an actor of the system into a misactor, and we've looked at the requirements and mined them for ambiguity, general being at the wrong level and missing the goals. We have to do what I call really the first step of threat modeling, which is starting to anchor it in the architecture. So let's talk about that a bit. We have to anchor this thing in the software architecture, not just the network topology. And we have to start to enumerate things like the business objects, sensitive data, and privileged functionality. This can't just be about the boxes and lines, and I'll give good and bad examples of this stuff. There are things that business stakeholders and analysts can do in this process, and there are things that developers can do in this process to augment getting each other's skills and get to the right level of diagramming to the point where you really feel confident that you're talking about the technology and the technical risks to it at the right level. I'll talk about some of the things you can look for when you look at middleware and open source and frameworks that are going to be fundamental and interesting to a threat modeling exercise. In my mind, again, the output of this really is just to drive your further assessment of the application and testing. Again, it's the rules of engagement and it's the plan by which you're actually going to test the application. It's just like any design review, right? When you've looked at the application at that level, you've hypothesized that there are vulnerabilities. You don't know that they're exploitable yet. This allows you to agree with the rules of engagement between development and security, to make sure that you've been thorough about enumerating all the things you want to enumerate, to go after, to prioritize them based on risk, and then to establish a tie in the architecture, in the design, between the vulnerabilities and the controls, right? This is really sort of a format for diagramming and design discussion. You still have to bring to the table your security knowledge. You still have to bring to the table your development capabilities and your understanding of the software and its business, its actual goals. And you still have to do the thinking of figuring out what the threats could entail. And so I'm going to jump into an example really quickly, just to mention kind of some of the technical, some of the design discussion that can come from looking at where the assets in your system flow and what's available where. And so when you think about systems and you think about when you think about where information exists in the systems, remember anyone call up tech support to ask for a password reset. Right? This is a password reset, a workflow that every system has, right? And it's an interesting workflow because it's a workflow that's going to involve some sensitive data, right? And it's going to involve credentials to the system. And And what's funny about it is when I call tech support and I forget my password pathologically, because I make ridiculous passwords. You know, it's funny when I call these guys up and have the conversation with them, because when I talk to them, you know, I can almost see the interface they're looking at, right? And so, you know, when you call these guys, they always ask you for your name, and then they ask you, you know, are you the guy at Mirror Way? And I say yes, right? And when I say yes, I know that they're already considering that information, because for them to ask me that question, that means that the person in the call center I called, when they typed in my last name, got basically a pull-down box or something, right? And all of you know that, you know, after they've verified that you're the person, right, the particular John Stephen, right, or whomever that you're calling, they ask you the canonical question, right? For security purposes, verify the last 4 digits of your social security number, right? And so when they ask you those questions, you know, you're almost assured actually that they're looking at your social security number. And you can actually play around with them to figure out if they are in some social engineering ways. And what's weird about that, right? So what does that mean? That means that when they're building, you know, so when someone was building this system, they basically, when they look, you know, when the CSR is looking at that GUI, that means that information, which is undoubtedly databased as, you know, part of my account information, that information had to flow throughout this entire system. You know, and I know that based really just on the interface design. And, you know, so whether this is a thick application or whether it's a web application, just looking at the interface will tell you what information is kind of available. And what that means really in terms of sort of, you know, secure design is that not only do I have to protect that data as it rests in the database, and we know tons of attacks that can, you know, help us out there, but I also have the job of protecting that data in transmit, you know, here, you know, as well as in this system, and then, well, you know, when it gets transmitted to the CSR. So I've now sort of bought for myself design problems because of that design, and because I'm, you know, presenting that information to the CSR. And so now I know that asset actually flows throughout my system. And one of the things we'll talk about when we get to trust modeling is that this notion that we can draw a box around the database and say that this database host is trusted because it's in our LAN is kind of silly, because the database doesn't do its job unless it's really returning all of the data inside of it to the application. And if you're using things like Hibernate and Spring and Castor and those things as persistence and DAO frameworks, those frameworks' job is to replicate all of the data in another tier. And so in essence, I'm now placing those 2 tiers in an equivalence class of trust. One of the things that I know people have started to fail when they're doing threat models is when they draw a box around each of the hosts in their application and say, this is a trust zone, this is a trust zone, these are all unique. If your system is behaving like every system I've seen, data's flowing throughout it. And so it makes a lot more sense to figure out where the data's flowing. And it's not just the data that flows, right? It's things like error messages, and this is just sort of a bonus. I saw this in a cab when I was actually on a call to do architecture analysis. Your data goes over the wire, we don't care, just pay in cash. So I guess this is one of those compensating controls. So what does it mean to diagram the application at the correct level? You know, we're all familiar with these kind of diagrams, right? They usually, the wall has a fire on top of it. There's systems, there's clouds, there's dotted lines between them. Just not very useful, right? I can't talk about what any of the software components of these systems are, and therefore I can't talk about the vulnerabilities that are intrinsic to the design of those frameworks and the use of that software. When I start to build, you know, diagrams, and this is really fuzzy as well, and I talk about, you know, basically that I've got this MS SQL server and I have this layer of stored procedures and I have 2 different data sets sitting on top of that. It's kind of interesting because I'm talking about, you know, co-locating data and sharing things. I have some notion of you know, breakdown between the tiers and what flows over them. Still not really the same level. In my mind, there's no one-size-fits-all. Network topology as diagrams are a failure mode. The UML and the DFDs that we saw in the Microsoft model are also a failure mode because they're kind of too low level. And when we've just got boxes that represent each of our hosts and spidering lines that connect them, and we call each a trust zone, that's also a failure mode. A one-pager is important, but you'll notice that we keep layering on top of it aspects that will drive much better detail. So from our previous example of the social security number and password reset, what would be better is to show kind of where authorization to the system flows, and to show what modules, and if you look at what Dennis has done with O2 and F1, he's really helping you do this visually, right? But actually reverse engineered from the application, and this is something we've also worked to build plugins to do as well. So you can actually get the authoritative answer to where the equivalence classes of particular servlets and beans are. But just being able to color what roles have access to what components gives you an interesting view of the system. So if you've got normal user functionality in blue, and you've got privileged functionality in red, and you've got admin functionality in yellow, interesting points become where these boundaries begin to change. So in your session beans, when you have normal user session beans using entity beans that have a higher privilege, what is preventing a privilege escalation across that boundary, right? If you're using something like struts or springs to drive your controller, and you have one of these boundaries there, is it possible to manipulate the URL to just, if you know about the privileged functionality, call it directly, right? Because of all this is dispatched through a single front controller or something similar, some mapping in the deployment descriptor. And when you look at the work that Ounce did, that's really what they were discovering. They were discovering that, in fact, the Spring framework basically sits below things, and based on the input parameters you give it, dispatches different functionality. And so, any organization that had already colored their diagrams and said, across this line, I'm going to do an additional authorization check, was safe against some of those things. Those of you who are familiar with Gunner's talk, he hits this concept a lot, trying to figure out from an authorization perspective where there's a difference between the level of resolution you're able to make decisions on is very interesting as well. So you've got thousands of users and you've got credentials per session here. Back here, you have application credentials one-to-one between the application and the database. So are you using a particular element of Oracle that is helping you pass another parameter across this connection level security that's going to do table level authorization checks on your accesses here? Or is you simply confounding your capacity to make decisions in this tier because you're taking thousands of users and mapping them to one user Oracle with the password Oracle when you connect to the database? So you can look at where the coloring, so to speak, of different authorizations should exist and start to map things into buckets that way. You can look at the resolution you're capable of making decisions based on as you transfer in between tiers as well. This is just there's other things you can do, interestingly enough, just based on the structure of your application. And I apologize for time. I'm rushing through this. We can attend to all these details in greater length afterwards if you desire. Just looking at every design pattern you implement, model view controller being a design pattern, each of these design patterns is literally pregnant with responsibility in terms of security. So if you've got a model, a view, and a controller, you expect that the controller is responsible for application navigation. As a security architect, as someone who's looking at diagramming and understanding where the application could be vulnerable, you know that the controller has responsibilities that should never flow to the view. For instance, deciding whether or not someone's authorized to navigate, deciding where they navigate to. These are all controller elements that people will very frequently, with JavaScript and other client-side technologies, migrate into the view for performance reasons, and then end up with client-side trust issues. So as you look at the structure of your application, just saying to yourself, well, what design patterns am I using, and what are the security implications and responsibilities of elements of that design pattern would be very helpful. And if the guys who built Spring had done that, we'd be in a different boat. Likewise, we have different expectations of the model. Interestingly enough, in our organization, when we do assessments, we have a checklist, literally, that goes along with the view, the controller, and the model. And when my consultants go out to do reviews, my hope is that each and every one of them will assign, basically, membership in the elements of the design pattern, the applications they're looking at, and then run that checklist. Are they doing authorization checks over here and not here? You know, are they allowing model update from the view as well, or from the controller as well? Mm-hmm. I know. Component diagrams are valuable because in my mind they provide, and especially when you've annotated them on top of things like this, because they provide you capacity to understand where your choke points are in your design. When you're talking about transferring between identifying what could go wrong and where the controls should be put in place, you're going to want to know where your choke points are, because that's going to help you make decisions to solve a problem one place as opposed to 2,000 places. So to Dennis's point earlier, if you have 2,000 SQL injections returned by a static analysis tool, do you have 2,000 problems to fix? Or is there a place in your design where you can abstract away input validation? Understanding where the frameworks sit and what behavior sits on top of them is fundamentally essential to any threat modeling exercise. Because no matter how much code is written in your application, unless you're really a do-it-yourselfer, and you know, not invented here is your mantra, there's going to be more code underneath you than there is that you're responsible for. And you know, in the example I've beat up, each of these frameworks has very, very rigid design assumptions based into it, and those have implications about navigation, about trust, about authorization that are important. And understanding where each of your components sits is going to be essential to understanding where assumptions may go wrong or not. If you have portions of your application that are built on top of a CG, you can make strong, fine-grained programmatic checks that are configured declaratively about your application, and you have a rich capacity to do authorization. But what about these other, you know, these other beans that are not leveraging that? They basically, their security model is either hand-rolled programmatic or it's based on the deployment descriptor, and then the question becomes, is there access to them from a path that does not consider a CG? You can start to think about, in terms of the service to these components, whether or not they're providing security services to them up or down. Are some of these containers that are providing encapsulation, separation of address space, memory management, authorization to the components on top of them? In addition to where authorization and authentication decisions get made, just figuring out where the assets flow in the system is interesting. So one of the things we've started doing is starting to basically put a tick mark or put some icon in every module that has access to a particular equivalence class of data in its sensitivity. And it's really fascinating to see where some of those pieces of data flow. And what you'll find actually usually is that almost all the data flows everywhere. And so if you were to overlay a diagram like this with the diagram of where authentication and authorization decisions are enforced, you'd find a very fascinating mismatch, right? You'd find that, in fact, without fail, data is available where the authorization decision has not been enforced. In some sense, I'm starting to believe that just drawing a diagram with threats on it and having sort of the missile command from like 1980 something, these are all the attacks that could occur, is a failure mode. people who have said, okay, well, this threat can do all of the OWASP top 10. Well, okay, so put those tests, in your test suite. Yeah, use a tool to find them. Let's think about, again, the logic problems and the misuses that can drive problems in the application, rather than muddying a diagram with a bunch of arrows. Now, the thing that's valuable about writing down the arrows in an application is very simply that you can begin to select exactly what you're going to attack in the application based on these arrows. So, for instance, if I have a threat that basically is sitting on the internet and I want to attack something, an asset in the database, we all know as common knowledge now that I'm going to use some type of SQL injection or command injection on the database, and I can start now to select if I've got misuses and I've got abuses of the application motivating concerns. I can start to select my attacks based on where they'll target, right? This is something that will be stored and another user will end up displaying in their browser and executing. This is something that will run on the actual web server. This is something that will run on the database. And so what's interesting about that is now that I have the capacity to target a particular tier based on these vulnerabilities, I can now start to get beyond this ridiculous argument about whether or not insiders matter or not, and talk about how people on the internet can target an aspect of the system. Okay. So they're telling me I have only 2 more minutes. So I guess what I'll wrap up with is the take-homes of this really is to base the threat model in the software architecture, not the network topology. To use specific uses of the application to begin to figure out what abuse of the application could entail in terms of vulnerability, and then what motivated misuse could entail. Use that also to inventory the assets in terms of data as well as privilege in the application, and start to map that onto the resolution at which you can do things like authorization and entitlement and dispatch of that functionality. You've got resources for the low-hanging fruit. Concentrate your threat modeling exercises on actually figuring out what goes beyond those checklists and what problems could exist in the logic of your software, the business logic. And use the directedness of the attacks to point out where targeted attacks can occur in different portions of the containers and the tiers. And by all means, use this as a mechanism to drive security testing and assessment, not as something that you end up with a threat model for the application and you're done. This is a planning exercise, not a conclusive exercise. My guess is that I left a lot of questions. And so if you're interested, I will be around to answer them. Also, these slides are available, and there's, I believe, 80 of them. So they are well annotated in terms of notes. So feel free to look through them afterwards and follow up with me. But I appreciate the attention. I guess I'll turn over to questions.
We don't actually have any time for questions, but if you want to kind of ask questions as he comes off the stage here, you're welcome. We're going to be setting up